Hello, I'm Papia. In part C, we will have to differentiate the two explicit functions that we have found. So you remember that the functions are y equals positive square root of x squared plus 16 over 4 and negative of the same expression. Now, this is already in the explicit form. We just directly evaluate its derivative. But before we do that, let us rewrite the function a little bit so we know which rules of derivatives we have to use. So note that this 4 in the denominator is just a constant. So you can write it as 1/4 times the square root. But we should not just keep it as square root. We should actually change it in the exponent form so that we can use the power rule. So we have the expression x squared plus 16. And then it's a square root means the whole expression will have a power of 1/2. So in this form, we know that we have to use a power rule here and then also a chain rule, because this is not just x to the power 1/2, it's an expression to the power 1/2. So continue, and next step, let's just find the derivative. So what is y prime? The 1/4 is a constant, it stays as 1/4. Okay, so for the function itself, one more time, it's chain rule. So the outer function is the exponent 1/2. So you're using the power rule. So you bring the 1/2 down, and then x squared plus 16 will have a power of 1/2 minus 1. That's just using power rule. Then you have to move to the inner function and take its derivative. All right. What is the derivative of x squared? 2x. What is the derivative of 16? 0. So that's it. That portion is the chain rule part, and we just completed the derivative. Let us simplify this expression a little bit. So the constant is 1/8 because it's 4 times 2. And x squared plus 16 has a power of 1/2 minus 1, so that's negative 1/2, times, you can ignore the 0, so this is just 2x. Now notice we can cancel out the 2 with the 8, so you get a 4 here, and we'll have our expression. So let's see, the denominator, we have a 4. Notice, even though x squared plus 16, that expression looks like it's in the numerator, it's actually not because of the negative exponent. So we can make it a positive exponent by bringing the whole thing in the denominator. So in the denominator, we'll have positive 1/2 as the power, so it'll be a square root of x squared plus 16. And remember, there's this x that stays in the numerator. So this is the simplified form of the first derivative of the first explicit form that we have. So let's think about the second explicit form. Note, if you just ignore the negative sign, this part, this expression, is exactly like the first explicit form. So its derivative will be exactly the same one, except we will have to put the negative sign in. So you don't have to do the whole thing again. You know right away that this derivative will be negative x divided by 4 square root x squared plus 16. All right, so in part C, we have differentiated both the explicit forms, and we got our 2 derivatives here. Let's move on to part D. In this part, we take our original equation, that's an implicit form, and we have to find dy dx, which is the derivative of y. We have to find that again, but implicitly. All right, let's be careful. Look, we have to compute dy dx. So you take this portion, the d dx, and apply it to both sides of the equation. So first step will be, we do d dx of 16y squared minus x squared, and right hand side as well, This is equal to d dx of 16. It's a good idea to write it down so that you notice where you have a different variable y and the same variable x. So it's always a good idea to write it down. Now, let's just solve this problem and find the derivative of each term individually. So first notice the first term is 16y squared, and we are doing d dx of it, right? So here is x. We're taking the derivative with respect to x of the variable y. So see, these are different variables. So you have to be very, very careful. Okay, so 16 remains as it is. And what is the derivative of y squared? Well, you use power rule, so it's 2 times y. But then this is y with respect to x, so you will also have the term dy dx. This is basically using chain rule. Think of y is like an expression to the power 2. Now, the second term is x squared, and you are taking the derivative with respect to x. Same variables, so the derivative is just 2x. Right hand side, this is a constant, 16 is a constant, and its derivative is just 0. So we have taken the derivative of each term. Now, let's solve for dy dx from this equation. Notice that we have a common factor of 2 from both terms. So we can pull it out, and we'll have 16y dy dx. And from second term, we have a negative x. That is equal to 0. So you can divide both sides by 2, and then right-hand side, you will still have 0, and you will get rid of the 2 from left. So you will get 16y dy dx minus x is equal to 0. Let's solve for dy dx. So let's move this negative x to the right-hand side. So we'll have 16 times y dy dx is equal to x. And then to solve for dy dx, we just divide both sides by 16y. So we get dy dx is equal to, we have x divided by 16 times y. Now notice that in part C and D, we are looking at similar functions. So we started with this implicit equation, and we solved for y, and we found these two explicit forms. So the derivatives that we got in the part C and the one we got in part D, they should be the same derivative, because the function that we got here and this equation, the graphs are similar, right? Now let's check that. Is this dy dx expression is the same as these two? Now notice that in this one, we have a y in the denominator, right? And we know that y is given explicitly right here, the two forms. So why don't we plug in these expressions for y and figure out what the dy dx will be? Okay, so let's first plug in y equals positive square root x squared plus 16 over 4. Then we will have x divided by 16 times, I'm rewriting y now, is square root of x squared plus 16 divided by 4. Okay, the 4 cancels with the 16, and this is equal to x divided by 4 square root x squared plus 16. Remember, this is dy dx when you plug in the first explicit form of y. And look back here. The first explicit form of y gave us this y prime. Look, it's exactly the same one. So this one is exactly the same as the first expression that we got here. So what happens to the negative? If we plug in y equals the negative of that expression, of course we'll get the same y prime again from part C. So for the second part, we just plug in y equals negative square root x squared plus 16 divided by 4. As you can see, again, 4 and 16 will cancel, and you will have x over 4. Okay, this negative sign in front of the square root, it doesn't matter where the negative sign is. Remember, this is multiplied, so that negative sign can be brought in the numerator as well. So you can make it a negative x divided by 4 square root x squared plus 16. And again, that's exactly what we achieved here as the derivative of the y from the second explicit form. So we checked our result. Both derivatives that we got from the explicit forms and the one that we got from implicit form, they are same. Thank you.